Fifth task, constructing faults. What do we do for this? We need to build reference points. Reference points are points on which the fault plane rests, lying on the surface of the point. These can be waypoints or artificially created points. If you, for example, interpret an image, a satellite image or an aerial photo, then you can use these virtual points to build faults. As a result, the proper planes will be created if we build by points. Let's set the points. To do this, we recommend using a utility layer. There is a useful layer down here, 0. We turn off everything else. In this 0 layer, we will put everything that we will not need later, but for now we need in our work. In this case, we will put the reference points here. And then we begin to create these reference points. Go back to add point. And so we see that here we have a line, which is most likely a fault line. Here we put the first point on it. Let us call it 4. For convenience, let's take the icon of granites. And for convenience again, so that it is visible, we will make it bright yellow. Here. And let's increase the size of the cross. Here we can increase the size. We'll say 128, let it be. Here, choose Save Point. Now show its name. Show it. Fine. Save Point. Here we have it. That is its name. This is the point. Good. So let's create 2 more. This was our 4th. We are creating the next one. Let's put it here again. To this line. Name it 5. Show name. Granite. Size. Color. It remembered everything. Save. So this is the name of the point. Here we have it. So let's place a 3rd point. I'll tell you why later. So again we add a point. Here we put it on the line. This is number 6. Granite. Color. Size. Save. Oh, they forgot to say to show the name. So, choose Show Name. That's it, the name shows. Good. Here, this is the name of our 3rd point. Good. And then we have options for constructing a fault. We want to construct a fault. Again, we go to add an object. Choose fault. So 1 point at a time. Let's say we call it F. Yes, but we'll select a point first. Let's take the middle one. The middle one. It's a PTN 5. And we'll say no, it will be F46. Here, and then we choose what we should indicate. Dip azimuth and dip angle. So looking at the map, we determine that the fault steeply dipping in the southern direction somewhere. Here, it dips at about 150 degrees. Dip azimuth. This means we set the dip azimuth to 150. And let's say its angle is 75. Let's try yes. Here, solid line. Let's turn on the spline. Here, let's choose a clear red color for it. And let's say let the thickness be okay, let. Set the thickness to 4. Scale. Scale is important for custom line types like this. To make the teeth denser or sparser, for example on thrusts. Here now it is not important to us because it is a solid line. Choose Save Fault. And we have a line on the map. See? But it does not coincide with our ideas. So we start working with it. It should lie right in this gorge. Here. Now it is better to do it like this. Act. Oh, sorry. Here is the error. The fault layer must be editable, so you can work with it. And then, here, we have highlighted our fault. Now we do not go there anymore. We use change properties here. Here, and we tweak it a little. So it was 150. Let's set the azimuth to 155. And then just save. Right. Almost got it. Almost got it. But it feels like it is too smooth. Let's try to make the angle a little smaller. So, let's make an angle of 65. Save. No. We've gone too far. So we will make an angle of 70. We were close with the angle. Not good either. But still, the closest we had was 75. In general, this process can be done indefinitely. And each time the result will change a little. Here, let's leave it like that for now. Let's say we have a certain fault line. Let's try to build a fault using 2 points. It will be more accurate, because in this case the plane is determined by the machine. By computer. Here, and our task is to set the angle. Here, we are removing this fault. Here, again we go to create a fault. Let's talk 2 points. And we select a spline for this purpose again. So, we don't care about thickness. The color is red. Okay. Here. Here. Show points. This is where we have to select the points. Let's take the 5th and 6th. Let's try them. So he immediately suggests some kind of azimuth. But here, you see, this is the azimuth in the northern quadrant. It falls to the north, but it dips somewhere to the south. So we enter our 155 here. And it recalculates and corrects it. 148.7. Fine, but we must set the dip angle. We're talking 75. Just like we had there. Yes, and save the fault. See, it complains. This is the name it is trying to assign to the point name. But here the fault was called differently. We have to enter it again. Now it will let us save it. So, better now, right? Now let's try to change its angle. Yes. Let's make the dip angle steeper. Let's try it first. 80. Save. Oh, almost got it. Almost got it. Almost got it. But the most accurate option is to construct a fault from 3 points. And from 3 points hanging in space, having x, y, and z coordinates, it is possible to construct only one plane. That is, in this case, we will not be asked anything. And depending on the quality of our topographic base, the program itself will try to build a plane. You see, from 2 points, it seems to have worked well. Remember these values. What did we have there? 148.80. Yes. Fine. Let's remove this fault. Let's delete it again. And we build a fault from 3 points. So, fault from 3 points. And select these points. 4, 5, 6. And we remember that our computer complained. So we enter our fault name again. Next, we'll set up a spline again. Choose red for it again. Let's not touch the thickness. Save the fault. Right. This is what I was talking about. This means that we use a very low-detail topographic base here. Copernicus. Their contour lines are every 30 meters. That is, I'll just show it to you now. What these contour lines look like. It is dangerous to use them on difficult mountainous terrain. Because such miracles happen. Do you understand? This is a very low-detail topographic base. And these issues can happen with it. Our solution. So here we are again, turning off the visibility of this Copernicus topographic base. Here you see it. Turn it off. Here we stand on the line. Delete. It did not suit us. And we return to constructing a fault from 2 points. So we choose. As we already chose there. 5th and 6th. So, correcting the name. So, set our usual value, around 150. It will now tell us that there are not 150, but 148. And here we enter 80. We save the fault. I forgot to change its color. Let's change its color again. Make it a spline in clear red. Save. Oh, sorry. Like this. We saved a clear red fault. And now I won't go into what is right and wrong in geological terms. We will simply try to split the bodies that cross this fault with this fault. Select the body that it intersects. Here it is, our first. Oh, sorry. You need to make the polygon layer editable. You see, now 2 editable layers are selected. This is intentional, so one layer can split the other. You can only select 2 editable layers. Or 1. That's it, 2 editable layers. Now it's correct. Now click the needed contour. It is selected. Here we have chosen the body. And now let's try to split it. Split it with the fault. Here. It says it was split into 2 parts. Here we have 1 part. Here's the other part. Good. Let's split another body. Here we choose it. Here we are splitting it. Show the contour to split by. Here it is shown. Everything split correctly. Everything is fine with us. Everything is fine. With this, we have completed this task.